Okay, good morning, class. So today you have a sub, but we're going to go ahead and continue with section 4.7. All right, so and we're going to specifically look at the composition of inverse trig functions. All right, so here's what we recall from inverse functions. If f and g are inverses, then we know that f of g of x is equal to x. But that's only provided that x must be in the domain of g. So this x has to be in the domain of g. So x must be in the domain of g. We also know that g of f of x is going to equal to x. But again, only if x is in the domain of f in this case. So x must be in the domain of f. Okay, so this will extend to our inverse trig functions. So for sine, the sine of the inverse sine of x is equal to x, but that's only for every x that is an element of, well, the inverse sine has to be an element from -1 to 1. And the inverse sine of the sine of x is equal to x only for every x that is an element of a restricted domain, -pi/2 to pi/2. Okay. So for cosine, the cosine of the inverse cosine of x is equal to x, and that's for every x in -1 to 1, and the inverse cosine of x is equal to x for every x between -pi/2 and pi/2. For tangent of the inverse tan of x is equal to x, so these two undo each other, only for every x between -infinity and infinity, so basically all real numbers. But the inverse tan of the tangent of x is equal to x. So remember, we restricted our domain for tangent of x between -pi/2 and pi/2. So for every x, so it's non-inclusive of the pi/2 because those are asymptotes. Okay. So when we're evaluating the composition of these inverses here, the inside function, you have to determine if x is an element of that domain for the inside function. If not, then we have to do something else. So take a look at this example. what is the inverse sine of the sine of pi over 4? Okay. So here, the inverse sine of the sine of pi over 4. All right. So our domain for the sine, our restricted sine function, is from negative pi over 2 to pi over 2. So our answer here would be pi over 4, because pi over 4 is an element of negative pi over 2 to pi over 2. So pi over 4 is in this domain. But take a look at this next example. How about the inverse sine of 5 pi over 4? Well, the answer here is not 5 pi over 4, so I just can't let this inverse sine and this sine undo each other and our answer be 5 pi over 4. Because 5 pi over 4 is not in the domain of negative pi over 2 to pi over 2. Okay? So the answer here is not equal to 5 pi over 4. So what we have to do in this case is we need to first evaluate what the sine of 5 pi over 4 is. So sine of 5 pi over 4, 5 pi over 4 is in the third quadrant. Sine is negative there. So sine of 5 pi over 4 would be negative square root of 2 over 2. So now we're going to replace this sine of 5 pi over 4 with the negative square root of 2 over 2. And now our function becomes inverse sine of negative square root of 2 over 2. So the inverse sine of negative square root of 2 over 2 is negative pi over 4. Negative pi over 4 is an element of negative pi over 2 to pi over 2. So that's our solution there. Okay, so now let's take a look at this example. The cosine of the inverse cosine of 0.6. So the inverse cosine, its domain goes from negative 1 to 1. So 0.6 is between negative 1 and 1. So the cosine of the inverse cosine of 0.6 is going to just be 0.6. Since 0.6 is an element of the set negative 1 to 1. Okay, example B. The inverse sine of the sine of 3 pi over 2. Okay. So here, we restricted, so our answer here is not equal to 3 pi over 2, because we restricted the sine from negative pi over 2 to pi over 2. So what we're going to have to do here first is we're going to have to evaluate the sine of 3 pi over 2. So the answer here is not equal to 3 pi over 2, since 3 pi over 2 is not in the set of negative pi over 2 to pi over 2. It's outside of that domain. So the sine of 3 pi over 2 is equal to negative 1. Now negative 1 is in this domain. So the inverse sine of negative 1 is equal to negative pi over 2. And that's our solution. Okay. Let's try a couple more. So take a look at the next example. Cosine of the inverse cosine of 1.5. Okay. So here, we remember that the inverse cosine is valid between negative 1 and 1. So the answer here is not 1.5, since 1.5 is not in the set of negative 1 to 1. So now we evaluate, or try to evaluate, the inverse cosine of 1.5. Well, the inverse cosine of 1.5 doesn't exist because cosine only exists between negative 1 and 1. So this one is not defined. Okay. One more example. Inverse sine of pi. Okay. So here we restricted our domain for sine between negative pi over 2 and pi over 2. So pi is not between negative pi over 2 and pi over 2. All right, so we have to evaluate the sine of pi first. So the sine of pi is 0. So we replace the sine of pi with 0. So the inverse sine of 0, now 0 is between negative pi over 2 and pi over 2, and the inverse sine of 0 is just 0. So that would be our solution. All right, so our assignment today, I've changed it around a bit. So our assignment today will be section 4.7, page 466, isn't it?